Okay, geometry class, we're going to be working on distance formula and midpoint theorem today. Okay, what does this mean? All right, so here's the essential question. This again means what you're supposed to get out of these notes. At the end of the notes, you should understand how you determine the distance between 2 points and how you can find the midpoint between them. So if I give you 2 points, how do you find the point exactly in the middle? And if I give you those same 2 points or any 2 points, how do you find how far apart they are? It seems simpler than it is. You can't take out a ruler. Okay, we're talking about random points in space. So if you have to, go ahead and pause this so you have time to write it down, but this goes into your notes. I'm going to keep moving, so hit pause if you want to stop for a second. All right, so the distance formula. Okay, what does this mean? Well, let's say I start with any 2 random points. What I want to know is basically how far is the distance between those 2 points. And by that I don't mean inches, centimeters. I mean, if that's a 5 and a 6 and a 4 and a 2, how far apart are they? I find it easier to look at a specific example. So let's look at this specific example right here. What I want to know is, what is that right there? What is that distance? Okay, first thing I want you to think about, and see if this makes sense to you, is every 2 points that you plot, either make a straight line or you can make a right triangle out of them. So I kind of want you to think about that and make sure you believe that. Okay, now here's my logic. So any 2 points I make, I'm saying I could then create a right triangle. Okay, and I think that seems pretty obvious on that one. As far as a straight line goes, what I'm saying is if the points are directly either across from each other or one on top. So if I either have this right here, that's a straight line. Very easy to count how far apart a straight line is. In this case, it goes from -8 to 1, so that'd be 9. Similarly, if I had these 2 points right here, straight up and down, okay, then I can able to count 0 to 6 is 6. So either it makes a right triangle or it's a straight line. Okay, so what we're going to do is we're going to go ahead and form that right triangle. So I'm going to draw the one leg there, the other leg there. Notice then that this forms my 90-degree angle right here, which means if I draw a line straight out, that's my hypotenuse. So what I need to do is figure out what are those sides. Well, this is 8 minus 2, which is 6, and I want you to pay special attention to that part right there, the 8 subtract the 2. Okay, I can do the same thing on the other side. I can take 4 minus a -4, which of course turns into a plus sign, which equals 8. So now my legs are 6 and 8, and my hypotenuse is d, so I'm going to set that up. Leg squared plus leg squared equals hypotenuse squared. 36 plus 64 equals d squared. So 100 equals d squared, and when I take the square root of both sides, I get 10 is equal to d. So again, this part right here down at the bottom, this is the part I intended you to have in your notes. If you wanted to write all this stuff up above, that's fine, you can, but that's not what my intention is. And the reason I wanted to give you this specific example is so you could see the process, okay? No matter what 2 points we have, we're going to be looking at making a right triangle using the Pythagorean theorem. We're about to sort of come up with or derive what we call the distance formula, and really what the distance formula is it's just a right triangle, okay? We're saying that we're going to take 2 points and we're going to make a right triangle out of them, except we don't have 4 and 8 and -4 and 2. We have just sort of any 2 random points. So what I like to call the general case, which means no matter what. First thing you do is you pick two points that aren't specific numbers, okay? Because even if we pick any 2 numbers, you could always ask, well, what if the numbers were different? What if they were fractions? Or what if they were 0? Or what if they were negative? Or what if they were very large numbers or very small numbers? So obviously, we don't want to have to try every single possible combination. So what we do is we pick numbers that can be anything. Now, originally I have 2 points, x comma y and x comma y. However, I don't want to leave those points like that. And the reason is we need 2 points that we can actually have as general. Okay, right now if I were to take y minus y, I'm going to get 0. So what we do is we switch those out for x1, y1, and x2, y2. And those are, it's hard to see on this computer, but basically they're subscript, so it means it's a little bit lower than the number. And the purpose of the subscript is to signify difference. So x1 is different than x2, y1 is different than y2. Now we're going to do the same process. We're going to make a right triangle. Okay, and we're going to think about what would be my sides of my right triangle. Well, just like before, that would be whatever y2 is. If it's 100 or if it's 10 or if it's negative 50, it would be whatever y2 is subtracting whatever y1 is. So again, we're keeping any number. Any number works for y2. Any number works for y1 right now. Same thing for x2. X sub 2 minus x sub 1. Again, think any number you could possibly put in, that would still work. Because even if they come out to be 0, it's still fine. Okay, we apply the Pythagorean theorem using these sides. So we've got, instead of last time like we had 6 and 8, we're just going to, in parentheses, put the y minus 2 and the y minus 1, and the x minus 2 minus the x minus 1. So if you look, here are my two pieces. It looks a little different, but this is my leg squared, and this is my hypotenuse squared. So if you look at it, it's really the same thing as we've been doing. The next step in the Pythagorean theorem is usually to combine those things, but we can't. We don't know specifically what those numbers are, so we would then just take the square root of both sides. Because remember, that's the last thing to do. We ended up with 100, we took the square root, we got 10. So what we have right now, this right here, this is the distance formula. And you'll see in your notes I've already typed it out for you. It doesn't matter if you have x and x2 minus x1 first or y2 minus y1 first, because of two reasons. One, if it's squared, it's always positive, so that meets the first requirement of the commutative property. Second is we have addition in the middle, so basically what we're saying is you can add any things in any order. So it could have been y first or x first, but the general formula you see in the books will be like this, probably with the d on the left side. So as I said before, this is called the distance formula. And the basis for it is sort of the proof for it, so to speak, is to understand that no matter what, every single 2 points you possibly plot could be turned into a right triangle. As long as you believe that, then this formula is obviously going to hold true. Because every right triangle has the Pythagorean theorem. Okay, so what I want you to do now is on your notes, you've got a few examples, and we're going to do one at a time. Please don't jump ahead of the video. Just go ahead and try it, check it, fast forward if you need to, and you should be able to do this quite quickly. So the first one, I want you to use the distance formula. We're going to do this together, and we're going to check to make sure that we can use the formula. So all we're going to do is we're going to start with the formula, and we're going to substitute in. Remember that this is my x1, this is my x2, this is my y1, this is my y2. It doesn't actually matter which one you put first because of the way squaring a number works, but I tend to prefer just to go in order to make it simple and easy to remember. So as you can see, I've substituted in my x and x and my y and y. I'm then going to take 7 minus 2 and 17 minus 5. Now I just square. 5 times 5 is 25, and 12 times 12 is 144. Last step is to add, and you end up with the square root of 169, which is 13. Okay, so here's one to try on your own, and it's on the right side of your sheets, I believe. So go ahead and pause the program. When you're ready, hit play, and we'll check if you're right. All right, so using the formula, we're going to plug in our x's and our y's. Double check that you've done that correctly. In this case, we both have minus, minus, and minus, minus, so those both turn into addition. That's why I get 12 and 16. 12 times 12 is 144. 16 times 16 is 256. Adding it up, you get 400, and the square root of 400 is 20. Again, feel free to use a calculator for these. I'm not testing you on your ability to do, 16 times 16, although I do suggest you know at least up to 15 times 15. Okay, another one to try on your own. Pause the video, hit play when you're ready. All right, so I'm going to start off by putting in my x's and my y's. It's a little bit simpler looking. I'm going to end up with 3 squared and 4 squared, which equal to 9 and 16, and added together give you 25, which of course the square root is 5. Okay, one more example. Go ahead and pause it. However, I want you to think about what this picture is going to look like if you were to graph these, because you might find that you can do this problem a little bit quicker. All right, so plugging in my x and my y, I have 7 minus 0 and 3 minus 3, which gives me 7 squared plus 0 squared. That then equals 49, and the square root of 49 is 7. What I wanted to talk about here is if you were to look at these 2 points on a line, however, you'd have 0, 3, and you'd have 7, 3. So if you think about it, what they do is they make a straight line. So you don't need to use a right triangle for this because the distance between them is kind of obvious. It's just 7 because we started at 0 right here and we ended up at 7. So we went over exactly 7. So if you look for special examples like that, you can do it, but it does require certain circumstances. And as you can see, the formula works every single time. Now what we're going to be doing is we're going to be talking about the midpoint theorem. Before we go into it, I'm pretty much, if you look at your notes, just giving you the midpoint theorem. The midpoint theorem is very simple, and we're going to look at why it's true in a second. But what I like to do in geometry is I like to have a reason why we know it's true. And what we're going to do is we're going to use the distance formula to prove it. So first off, let's think back of what we remember about finding the middle of two things in math class. I've heard people say median. Remember, median is, if you arrange them from lowest to biggest, it's the one that falls in the middle, which is kind of what we're looking for, but not really. What we're trying for is the thing exactly in between. And to do that, you use the mean, or also known as the average. You add the two things together and you divide by 2. So we're going to look at that specific example we did earlier. Okay, and this is the one with -4, 2 and 4, 8. First of all, if I wanted to find the middle, the first thing I would think is, okay, what about the middle of the x's? But as you can see, that doesn't make one point. Okay, I've got my x down below and my x up above, and both of those create sort of the same spot, which is right at 0, but unfortunately, that's not a point in the middle of the two lines. So next thing we would do, and that is found by adding the 4 and the -4 and dividing by 2, which is again the average. You add the two numbers, divide by 2. Now let's look at the middle of the y values, which is basically saying, okay, we're going to look at right in the middle of the two y's. When you do that, you can see we do hit a point, and that point looks to be pretty much right in the center. This one as well is found by taking 8 plus 2, which is 10, divided by 2, which is 5. And if you notice, they met right at 5. So if I'm looking at this point is 4, -4 over 2, and 8 plus 2 over 2. So you can see we're taking the average of the x's and the average of the y's, which ends out to be 0, 5. So again, you know we're going to do it. Let's look at the general case. What that means is for x1 and x2 and x2 and y2, what we're looking at here is I want to find that point that's dead in the center. Okay? And my guess, based on what I just noticed on the last one, is that probably what I do is I add my two x's together and divide by 2, and I add my two y's together and divide by 2. And it turns out that is in fact known as the midpoint theorem. However, in our class we've talked about conjecture versus theorem. I'm pretty sure that's right. It seems like it makes logical sense why it's right, but I don't have an actual proof of it. So we're going to look briefly at how to prove it. However, this is not going to be in your notes, and I'm not going to necessarily test you on this. What I want you to be able to do is I want you to have an understanding of why it works. So the question is, how can I prove it? Well, for starters, if I wanted to prove that that's in the center, what I would also be trying to prove is that I've cut that line in half. Okay, what that means is that's like saying this right here, this half, is equal to this half right here. Now, if I place any point anywhere on the line that's not in the middle, that would not be true. So what we're going to look at to make it simple for ourselves is we're going to go ahead and we're going to basically right off the bat what we're going to do is we're going to go ahead and we're going to label it. Okay, P, M, and Q. And the purpose of that is to say, okay, now what I want to prove is I want to prove that PM is congruent to MQ. Okay, and again, what that means is that means that this section right here, whatever this is, call it X, is the same as this, also X. If I can prove that, then I'd be proving that that point M is directly the midpoint of those two lines. So what we're going to do is we're going to use the distance formula. Remember, the distance formula says you take x2 minus x1 and y2 minus y1, you square them, and you add them together and take the square root. So what I'm going to try to do is I'm going to try to do this basically. I'm going to say I'm going to look at this right triangle, and I'm going to look at this right triangle, and if I can show that the hypotenuse of these is the same, then I will have proved it. Okay, and there's honestly a lot of ways to do it. We're going to use the distance formula to prove it. You can also do stuff with similar triangles, but since we haven't covered similar triangles, this is going to work to prove using the distance formula. So first off, we're going to start with PM. This is where things are going to hit you and be a little confusing, so you want to follow along. Basically what I'm looking at here is I'm looking at the distance formula, so x2 minus x1. And the confusing thing here is when I talk about x2, I'm talking about this part right here. Okay, I'm saying the second point on the line. Remember, I'm only looking at this piece right here. The second point on my line has an x value of that. That's why it's right there. Let me use a different color to make it easier to see. Okay, so that's that piece. Okay, my second part, my x1, comes from this right here. And so that's subtracted right there. So you can see it's the same formula we used before. We're taking the second point and subtracting the first point, and then we're squaring it. The same thing is true for the y. Here's my second part of the y, and my first part of the y. Together they are subtracted and then squared. The last step is to take the square root. Okay, so we're going to start with what we had before. And what we're going to do right now is we're going to try to give this a common denominator, meaning I want them both to be over 2. So I'm going to put this over 2, but I can't just do that. I have to put a 2 in front of it. Same thing here. I'm going to want to put this over 2 and put a 2 in front of here. And that's just giving it an LCD. Okay, so you can see here I've given an LCD, and now I've put all of them on the top of the fraction. Now what I'm going to do is I'm going to look at this part right here and realize that x1 minus 2x1 is just negative x1. Same thing over here. y1 minus 2y1, that's also equal to negative y1. So that's how I get to right here. This piece right there combines to equal that, and this piece combines to equal that. And you may want to pause it and kind of look at it and make sure that makes sense to you. Simple way would be something like x minus 2x is equal to negative x. And it's kind of the same thing we're doing here. It's just with the y1s and stuff, it might be a little confusing. Okay, so that now is as simplified as I'm going to get it. And we're going to come back to this. What we're going to try to do now is we're going to try to show that with MQ, I get the exact same thing. If I do, that means they're equal to each other, and that means we're done. Okay, and that's another property, a very common property that we're going to look at later. And what that property is sort of says like, well, if x equals 3 and y equals 3, since they're both equal to the same thing, that's how I know that x equals y. Okay, and I believe it's called the transitive property of equality. Okay, so now what we're going to do is we're going to look at the second piece, which is up here. We're going to look at the right triangle associated with that. So now I'm going to have y2, whoops. So now what we're going to have is we're going to have our y2 value here, and that is a second part of our point now. And the first part of our point is right here. So when you look at this, that's what's going on. Okay? Now what we have, as you can see, is we have our y2, which is right there. And we have our second, which is basically our y1, which is right there. Same thing is true for the x's, as you can see. That goes there, and that goes right there. Okay, so let's start where we just left off. Two things are going to happen right now. First thing, I'm going to give it a common denominator just like before. Give it an LCD. Okay, second, in addition to that, when you subtract two things like this negative sign has to get distributed to both parts. So what's going to happen is you're going to get a minus y2 and a minus y1. And that's where this comes from right here. So again, that's giving the 2x squared a common denominator. Now obviously, if I have this right here, this is equal to 2x2 minus 1x2, which is 1 left over. Similarly, 2y2 minus 1y2 is 1 left over. And that gives me the simplified form. What I'm going to do now is I'm going to put what PQ is equal, or sorry, PM was equal to above, and I want you to compare them. As you can see, they are identical, and what that tells me, since they're the same, the sides must be the same, and because of that, it's proven for all possible points. And if you don't understand why it's proven for all possible points, just think, could I put any x2 in there? Could I put any x1 in there? Any y2, any y1? If that's the case, if any point could possibly be plugged in and it wouldn't change what happened, then you know for a fact that you have proven it. Okay, so I know that's a lot, so let's go ahead and try it out. So we're going to use our first point here, and we're going to apply the theorem. Remember, we don't need to do the whole proof. The proof is just showing, yes, the theorem does in fact work. It means, yes, in fact, the formula is x1 plus x2 over 2. So add your x's, and then add your y's. Very simple idea. Makes perfect sense if you think about average and you understand it, but something that we wanted to make sure we knew for sure was right before we started using it. So starting off with the formula, we're going to substitute in x's and y's. You have to add the top up, and then at the end you have to do a division problem, 10 divided by 2 or 22 divided by 2. So we end up with 5, 11, and that's the midpoint. All right, so here's one for you guys to try on your own. Pause the video while you try it, and hit play when you're done. All right, so starting off here, we're going to substitute in our x's and our y's. Make sure that you've done that correctly. Then we're going to go ahead and simplify that. We end up with 6 over 2 and 0 over 2, which is 3, 0. And that's the midpoint of those 2 points. Okay, again, go ahead and hit pause. When you're done, hit play and we'll go over it. All right, so here's the formula. Plugging in x's and y's, I end up with negative 8 for my x's over 2 and 9 over 2. And a lot of people get confused here and they think, oh, I can't divide 9 by 2. You can. You just get a decimal of 0.5 or a 1/2. So negative 4, 4.5 or negative 4, 4.5. Typically, though, in points, you would see 0.5 rather than a half. But either one is technically correct, and I'm not going to mark it down. Okay, another one to try on your own. Pause the video, hit play when you're done. So plugging in my points, I get negative 9 plus 5 and 7 plus 3, which gives me negative 4 over 2 and 10 over 2. Simplifying out, I get negative 2, 5. All right, so what I want you guys to do now, we did this lesson in class, then you will not have a form to fill out below. But if you did not do the lesson in class, you definitely want to go ahead and fill out that form. Or if you're absent, that's a good way to show me that you've done the work necessary for that you missed. So please do fill out the form below, answer the questions, and I'll see you in class tomorrow.